9 has only taken the X-37 into low Earth orbit, right? This one is launching on Falcon Heavy, which I don't know if you guys knew. It's got a little bit more kick to it than it's got a little bit more kick to it. So this is going to some type of crazy high orbit that the X-37 we know has never gone to before. Why is it going there? No idea. I don't know. If I knew, I'd probably get in trouble for telling you. It's not going to Mars, as far as we know, and this is all public information. Like, you can get this information; it's out there on the internet. So we're doing a Tom Clancy. I'm not saying anything that you couldn't go and find. This is a 48-degree inclined insertion out of Kennedy Space Center. So the flight azimuth would probably be, I don't know, like 45. Actually, it would actually be more like 50. Actually, no, wouldn't be 50. It would be more like, it's the reciprocal of 45. So 35-degree flight azimuth out of the Cape. 36, 37, maybe even 40 out of the Cape to get to that 48-degree inclined orbit, right? So what does that mean? Well, orbital inclination is the tilt of an orbit relative to the equator, the equatorial plane of the celestial body that it's orbiting around. So if this is the, Earth's right here, if this is the equator, the X-37 on this Falcon Heavy is going into a 48-degree inclined orbit. So the tilt is 48 degrees off of the equator. Now, the X-37, as far as we know, has never gone into an orbit like this. And for a low Earth orbit insertion, right, you don't need Falcon Heavy. Unless the X-37 is carrying lead in its payload bay, which or like tungsten or something. You're not going to need that big of a rocket for a low Earth orbit insertion at that tilt, right? So we know that this is going to some type of high orbit. Interestingly enough, the information where apogee is set to be is actually out there as well. The apogee is geosynchronous altitude, so 23,500 miles. That's the highest point in its orbit. So 48 degrees inclined at 23,500 mile apogee. That's what's called a lightning orbit, a Molina orbit. The reason why it's called a lightning orbit is because the satellite spends, as it does one rotation, it spends more than 75% of its orbit over the northern hemisphere. So basically the orbit looks like it's a huge ellipsis, right? It looks like this. It's not like a circle. It's a huge ellipsis that's 48 degrees inclined, and the X-37 will be spending most of its time in the northern hemisphere. It'll sweep through its perigee, or lowest point of its orbit, because it's down towards Leo, towards low Earth orbit. And then the apogee is going to be way up high. Now, that's the type of orbit you'd need a Falcon Heavy for, which kind of explains why it's launching on a Falcon Heavy. Fun fact, right? So, why is it going to this type of orbit? Why would you do that? Molina satellites are where Russian communication satellites are. Molina orbits. Here, do you want to see what they look like? I'll show you. So this is a website that I like called Stuffin.Space. In here. Inclination change will probably be involved, looking like a 79-degree incline from second stage disposal. Cool. So right there, those blue satellites are the communication satellites that Russia uses for communication. Now, other countries do that too, but other countries have communication satellites like, I don't know, here, let's use NASA's TDRS. The tracking data and relay satellites from NASA. See those ones? These are down at geosynchronous, right? The thing is, you can only go geosynchronous up to a certain latitude. So a country like Russia, right, that's situated high in the northern hemisphere, can't really do something like this. Now why? Well, okay, let's look at this map. Let's look at the equator. Let's look where like Tidris is, for instance. You do not have line of sight to a lot of your territory, right? So this communication network originated from the Soviets. The Soviets wanted a way to be able to communicate and they needed satellites to spend most of their time in the northern hemisphere. So that's why the name, even though it's basically it's called lightning orbit, right? It's called Molniya for short. And forgive me if you speak Russian. I know I'm not saying that right. Molniya, I think, is how they'd say it, but I have no idea. That's probably wrong too. I probably just made a bunch of Russian speakers laugh. Well, good. I'm glad I could entertain you, you dick. Anyway, so the X-37 seems to be going into some type of orbit that looks like this. Very, very tilted, with a very high apogee up at geosynchronous altitude, but not in geosynchronous orbit. Molniya. Yeah, there you go. But yeah, that seems to be where it's going. Now, I don't know. Are they going to go peep on some things? Maybe. Who knows? I have no idea. Now, Phil, what did you just link up here? The launch hazard areas for Falcon Heavy SF-52 OTV-7 from KSC 39A. This is going to be a double booster landing. Return to launch site. Estimated fairing recovery is 1474 kilometers downrange. That's, wow, 900 miles. That's a long way, dude. That's a long way, baby. Stage 2 inclination change to 79 degrees geostationary orbit. Inclination change to 79. And re-entry in the northern Pacific after 12-hour coast. Whoa. Is just read the instructions down for repair after 10:58. Yeah, but turnaround should be pretty straightforward. 79 degree inclination change. So you could do that if you have an apogee at 35. What's geostationary altitude in kilometers? 32,000. If you have apogee at 32,000 kilometers up, an inclination change would be relatively low delta V. You wouldn't need a lot. The Falcon 9 could use its onboard RCS. The second stage could do its onboard RCS to do that. Now, Phil, I want to point out that I'm fairly confident that the second stage, the inclination change for the second stage is part of the second stage disposal. I don't think the X-37, because it's post-payload deploy, I don't think the X-37 is going into that 79-degree orbit. I think they're doing an inclination change as part of the disposal burn for the second stage. Just read the instructions. It's already fixed. It's going out in like 3 days for the next Starlink mission. Interesting. There's a lot of people at Jetty Park. Well, yeah, double booster landings, of course. All right. SpaceX is live. Here we go. It should be visible on the East Coast, yeah. What's wrong with the drone ship? A booster fell over on one the other day, Yuri.
5, 4, 3, 2, 1.
That one. The one they just showed there with the dragon on top. It was that guy. Yeah, we lost 10. They lost 1058, dude. 1058 was the one that flew DM2. It actually broke. Sucks.
Stage 1 is transonic.
Yeah, Fly can look up sea launch. SpaceX has never done it, but it's been done before. Hey, Spoon. Happy holidays. Merry Christmas, buddy.
Looking at a live view
Happy New
of
Year,
Falcon
too.
Heavy on historic Launch Complex 39A at Kennedy Space Center, awaiting liftoff at 8:07 p.m.
Look at
Eastern
that
Time.
beast.
Welcome to our live webcast of the
The wind's
USSF-52 mission,
firework.
where SpaceX will launch the Space Force's X-37B Orbital Test Vehicle, or OTV, to space for its 7th
That is a
overall mission
monster
to
of a
date.
rocket, dudes.
The OTV payload will conduct tests that include operating the reusable spaceplane in new orbital regimes, experimenting
right.
with future space domain awareness technologies, and investigating the radiation effects on materials provided by NASA.
Oh, cool.
My name is Jesse Anderson, and I'm a manufacturing engineering manager here at SpaceX, and I'm excited to be here with you today, bringing you coverage of our 5th and final Falcon Heavy mission for the year.
Launch
9th
time.
overall
My
since
name is
first
Jeff.
taking flight in 2018, and 3rd Falcon Heavy launch in support of a national security space launch mission.
Cool.
And as 2023
Discovery, go
comes
and
to a
throttle up.
close, today's mission also marks
Yes,
our
Sebby.
95th
Well, the front
launch
fell
of
off.
the year, with our final mission expected to lift off from our neighboring pad in Florida in about 3 hours from now. And you can see both of those
They got
rockets
them both
there
teed
on
up,
your
baby.
screen. A big thanks to all of our customers and the SpaceX team for a record-breaking year. Now, today's mission marks the
Unbelievable.
2nd time the X-37B orbital test vehicle will take flight on a SpaceX launch vehicle. Some of you may recall the first flight on Falcon 9 back in September
Zeb?
of 2017, in which OTV-5 spent a record 780 days in orbit, breaking the vehicle's own endurance record. Here's a closer look at today's payload.
A good way to understand the X-37B is that it's a reusable satellite. It's also super freaking cool. Look at that thing. Watch the solar. Dude. Wait a minute. They showed the payload bay. Yeah, the solar panel. See, the solar panel folds out. See? It's a reusable satellite. Damn, that thing is cool. I don't know if I want 5. We'll see. Oh man, that thing is killer.
For those of you following along, you'll know that we stood down from our initial launch attempt for this mission on Sunday, December 10th, due to bad weather.
I'm gonna go over
on
there.
our second attempt the following day, during the count, our teams reviewed data related to system checkouts, which resulted in a no-go condition and decision to stand down from launch that evening. We rolled the vehicle back to our hangar at Launch Complex 39A in Florida to be able to further assess data and address any issues. And during this time, the payload remained healthy and all systems are go for an on-time liftoff tonight. Weather is also looking great for today's T0. Today's flight will be on the Falcon Heavy that you see there on your screen. This is essentially 3 Falcon 9 rockets strapped together, which means that it can carry much larger payloads, not only to Earth orbit, but to the Moon and Mars as well. Like the Falcon 9, Falcon Heavy is a 2-stage launch vehicle. The big difference is that the Falcon Heavy first stage is comprised of 3 cores, and Falcon 9 has only 1. Falcon Heavy has 28 engines total. Each one of these cores has 9 M1D engines, making for a total of 27 engines.
It has
across
something
all
on
3
board,
boosters,
Zombie.
which you can see there on your screen.
It's launching a little mini
The
space shuttle,
28th
dudes. Yeah.
engine is a Merlin vacuum engine on the second stage,
And it's
will power
going
the
far
payload to
away
its
because it
separation
has that
point.
pushing it up.
Now, altogether, the Merlin 1D engines at the base of Falcon Heavy produce 5
Discovery,
million
go and
pounds
Postal!
of thrust,
10
which is
subs!
equal to 18 747s at
Thanks.
takeoff. And in fact, the engines produce so much power that we don't run them all at full thrust all at once until after liftoff. About 2.5 minutes
Yeah,
into
I'll check
flight,
in. I'll
the
be
2
right back.
side boosters will separate from the center core and come back to Earth for near simultaneous landings at Landing Zone 1 and Landing Zone 2 at Cape Canaveral Space Force Station in Florida. This will be the 5th launch and landing of these Falcon Heavy side boosters, which previously supported USSF-52
Discovery,
and
go and
67,
throttle up.
Hughes Jupiter 3, and NASA's Psyche mission. Upon side booster separation, the center core will keep firing for about 90 seconds before shutting down its engines and then perform a standard stage separation from the second stage. We will not be attempting to land our center core today. For those of you looking closely, this is why you don't see any landing legs or grid fins on the center
Hey, what's
core.
going on here?
And moving
Hey,
towards
Super
the
Wayo.
top of the
Thank
vehicle,
you.
once the first and second stage
It's
separate,
raining,
the second
Ian.
stage will propel our
It's
payload
raining a
to
lot.
its intended orbit. At our customer's
Ewok with 100
request,
bits,
we will
thank
not be
you.
showing views of stage 2, so immediately after the Merlin vacuum engine on the second stage fires up, we'll be directing all of our attention to the landing of our side boosters. Now above the second stage is where our payload is safely enclosed inside of the fairing. The fairing protects the payload from aerothermal loads, heating, and contamination during ascent. Once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit.
Thank you,
We will be
Forlorn.
attempting to recover the fairing halves today with our recovery vessel, Doug. And
Guys, we're inside of 10. We're getting up to 10-minute mark here. I'm gonna run ads. I don't like running ads. It's not really my favorite thing to do, but also I don't want people to click on the stream and see a rocket launching and then immediately get an ad. So we're gonna run some pre-rolls. We're gonna disable the pre-roll ads here by running some now. So you can watch this launch uninterrupted. Regid, thanks for the 2-monther. I appreciate it.
Discovery, go at throttle up.
Wojo, oh my goodness. Another 10 subs. Guys, whoa.
is flowing through. Falcon Heavy uses 2 propellants.
Yeah, Farm, it
One
pisses
is a
me off,
refined
man.
form of
I wouldn't
kerosene
run them
called
at all
RP1 or rocket propellant
if I could
1.
help it.
That's our fuel. The other is our oxidizer, which is liquid oxygen, or commonly
Super, thank you
called
very much.
LOX.
I appreciate it a
An
lot.
oxidizer is a type of chemical that releases oxygen to mix with fuel and allows it to burn. Liquid oxygen is chilled well below its boiling point so that it has
so
a
much,
much
dude.
greater
I
amount
hate
of
them so
mass
much.
per
You have no
volume,
idea.
which
I hate
basically
them.
means that we can load more of it into the rocket. As a fun fact, the Saturn V first stage flown from this very pad on the moon missions also used liquid oxygen and kerosene.
A lot
In
more of
addition
it, but
to
yes.
these 2 propellants, we also use the chemical TTEB, or triethyl aluminum and triethyl borane, as an ignition source. The combustion of RP1 and liquid oxygen is what makes the rocket go or fly, and it's the TTEB that sets the match to the propellant mix. Today's mission is for the U.S. Space Force and is being overseen by Space Systems Command, or SSC.
Center core RP1 load is complete.
Hey, Jack.
Space Systems
Cactus Jack.
Command is the
440.
U.S. Space Force's
Welcome to
field
Mission
command
Control. You go at
responsible
throttle
for
up.
acquiring and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and
Nice,
from
Forrest.
space. For more on the SSC, let's take a listen.
Space Systems Command. I think. Pretty sure.
The ultimate high ground
The ultimate.
has no ground.
It's over. I have the high ground, Anakin.
The
Discovery, go at
satellites
throttle
I just
in
did,
orbit
Cyberwolf.
around our planet provide the critical infrastructure we use to
Sindri.
defend and protect the security
Thanks
and
for the tenor.
prosperity of this
10
world
months.
we all share. But space is no longer a benign environment.
Discovery, go at throttle up.
Adversaries and near-peer nations are actively working to dominate the most critical battleground of our day. At Space Systems
Hey,
Command,
Boncha.
the time to act is now. The race is on.
Race
Our
is
adversary
on.
is out there. They are going to work every day, trying to work harder, smarter, faster than us. But we are making sure that that does not happen.
The Guardians, airmen, and partners of Space Systems Command are working with unstoppable urgency to innovate and act now, delivering
Hey, Star.
solutions to emerging threats,
Aloha, man.
creating
What's up?
resilient space architectures
have you
we
been?
can all rely on, especially during times of crisis and conflict.
The fight could happen tonight, it could happen tomorrow, it could happen in a couple of years, but we need to start innovating now, and that's exactly what we're doing.
For Space Systems Command, working faster means breaking from the status quo.
New Shepard?
Exploiting existing space architectures and capabilities in creative new ways. Working with commercial industry, innovators and tech startups, and allied nations to exploit, buy, and build. To deliver better, faster, and more affordably.
We are advancing the space architecture that we have up there right now, making sure that it's optimal, making sure that we get new space architecture set up, prototyping, experiments to ensure
Thanks
that
for the 10 pack,
we can
man.
outpace the enemy tomorrow.
To maintain our lead in space, Space Systems Command has embraced a new culture, empowering its people to race forward, speak up, and connect with industry in unprecedented new ways.
Our people are agile, they continue our partnerships, they are working collaboratively day after day in order to contribute to the big warfighter purpose.
Space is a team sport. We have to work together to provide integrated, resilient capability and speed in order to fight through an contingency crisis.
Space Systems Command is moving fast to maintain U.S. superiority in space, running a marathon of sprints, thinking differently, acting boldly, empowering at every level. To
You
make
see that?
space
See that
work
equipment
for
she was
us all.
using? It's really high tech.
Space Systems Command. Space starts here.
At T-minus 4 minutes and 45 seconds, all systems are currently a go for an on-time liftoff. Next up, the trusted structure
Yeah, the
next
equipment
to the
is very
vehicle,
advanced.
which is known as the strong back, will begin to retract away from the vehicle, and that is in preparation for liftoff.
Strong back retract has started.
And there's that call out.
Jasper, it's some
Now,
component
you
in
can
there.
see on your
Yeah.
screen, just below the fairing, around the second stage, are some clamp arms, and they're starting to slowly open up. Once they are fully open, then the TE can begin to recline away from the vehicle. And the
I'm
vehicle
seeing no
is
skip
nearly
frames
fully
in
loaded
OBS
with
journey.
propellants and will complete at T-minus 2 minutes. And there you can see on your screen those clamp arms are opening up there. The range is green and ready to support.
Part of our
Weather is
nature,
90% go for
Not much we can do
T0,
about
so
it,
Except
except try to prevent it.
very great news with the weather. If for some reason we do not launch today, we do have a backup opportunity
like it
tomorrow
anyway, yeah.
around the same time. And there you
The
can see on your
clamps!
screen, the clamp arms are now fully open.
Watch
So
the
that
TE
TE
will
to the
move.
right of the vehicle that you see there, to the right of the fairing, is beginning to slowly move away from the vehicle. Additionally,
lock slot is complete.
What a beast.
Additionally, it is worth noting that at the request of our customer, we will again not be showing views of the payload.
Boosters are
We
gonna
will be ending
double
the webcast
RTLS.
just after Falcon Heavy's side boosters
Frontino.
make their
Or
way back
Frontino.
to land on landing zone 1 and landing zone 2
Yeah, see?
around the
Double
T
landings.
plus 8 minute mark into flight.
Okay. Guys, during the mission, I'll do calls.
Center
As-
core, lock slot is complete.
And
We'll
we
do the
just heard
calls.
that call out that
Spacecraft is on internal power.
Here, and we'll
Just
we'll
heard
go.
that call out that the center core liquid oxygen loading is complete. That
It's a little mini
concludes
space shuttle,
all
Charles,
first
yeah.
stage vehicle propellant loading. We are
Double
still loading
supersonic
liquid
retro
oxygen
propulsion.
on the second stage.
My
and that
favorite.
should conclude at the T-minus 2 minute mark, which will also conclude all propellant loading for Falcon Heavy.
They learn new stuff about rockets tech by optimizing existing technology. Does that make sense? There's nothing inherently new
You can
about
also
what
see
Falcon
these white
does,
clouds
like in
on your
terms of
screen.
technical
This is normal.
equipment.
This
It's just
is
bringing
us
that
just
all
venting
together to
out
make
the
something that
boiled
can
off
land.
liquid oxygen at the liquid.
Stage 2 lock slot is complete.
And there's that call out that stage 2 LOX load is complete. That concludes propellant loading on Falcon Heavy.
Okay. Strong back gas closeout should be happening. Yep, there it is.
Again,
right
those
in the
white
center.
clouds that you see around the vehicle are normal. That's us venting
It's
out
tying my shoe.
the liquid oxygen that has
Serious.
boiled off of the liquid surface
Yeah, there's a little mini space
out
shuttle
into
inside of
the
it, Frankie.
ambient air. Once that cold liquid oxygen meets that warm ambient air, it basically condenses just as you would see water condensing around a cold glass of water. The next event coming up will be Falcon Heavy in startup. That's at the T-minus 1 minute mark.
90 seconds.
Ground gas closeouts.
And now that we have finished propellant loading, we are also clearing out the liquid oxygen line on that transporter erector, and that's why you see a little bit more of those white clouds there on your screen. Again, at the T-minus 1 minute mark, Falcon
They're
Heavy will be
evacuating
in startup.
commodities
This is an
out of
autonomous
the pad
vehicle,
so the pad
the
doesn't
internal
catch on
flight
fire
computers
during
will
launch.
take over the launch countdown.
60 seconds.
Falcon Heavy is in startup.
Okay.
Great news. There's that call out. That Falcon Heavy is in startup. Now just waiting for the final call from the launch director.
Initiated the sequencer. Software on board the vehicle is now controlling everything.
Director, go for launch.
Mission director reports go.
And great news with that
40
call
seconds.
out. All systems are go for launch of Falcon Heavy with USSF-52.
30 seconds.
30 seconds.
Chat is go. Hey, Fred. All right, 15.
15 seconds. T-minus 10, 9, 8.
Sound suppression
7,
system
6
is primed.
5, 4, 3, 2.
Engine ignition.
1. Engines full power. And liftoff of Falcon Heavy.
Okay, SF-52 is in the air. Good separation. Everything looked great there.
Discovery, go and throttle up.
Falcon Heavy's lighting up the sky. I'm with the 25 subs. Thanks for coming back, man. Okay. Oh, beautiful. 30 seconds into the flight, Falcon Heavy's lighting up the night sky. The next call in the flight here at T plus 44 seconds should be power and telemetry.
Nominal power and telemetry.
There we go. Hey, RB. TWR? Yes.
At T plus 50 seconds into Falcon Heavy's
Next step
flight,
is maximum
under
dynamic pressure.
the power of 5 million pounds of thrust, Falcon Heavy
Vehicle
is carrying
supersonic.
OTV-7 out to space. Now we are coming up on max Q here in a few seconds.
Yeah, the X-37 is a light payload.
Max Q.
Maximum dynamic
And
pressure.
great call out there. We have passed through max Q. That is the point of peak mechanical stress on the vehicle, and we've now passed through that. So we do have a few events coming up here.
Okay. Come back. All right. Sweet.
That will be booster engine cutoff, or BECO, separation of the side boosters, followed by side booster boost back burn startup, and then the center core main
100
engine
seconds into the
cutoff,
flight.
or MECO.
Vehicle is traveling at 2,600 kilometers an hour, 26 kilometers in altitude.
Now again, those are a few events coming up here. BECO, side booster separation. That'll be the separation from the center core. The center core will continue to carry stage 2 with the payload until it shuts down its engines with MECO.
120, T plus 120, 3,700 kilometers an hour, 39 kilometers in altitude.
And there you can see on your screen, on your right-hand screen, some views from the side boosters.
We got good onboards, good views here. Should be coming up on booster engine cutoff, or BECO for short, in the next 15 seconds, and then booster separation.
Coming up on BECO in a few seconds here.
Just said that, Jesse.
Booster engine cutoff.
There's
Side
BECO.
booster separation confirmed.
Yeet! The two side boosters will now turn around and do double boost back burns to get back to the launch site.
And back so.
Should see some really nice plume interaction here. Boost back burn startup should be happening right around
now. Able to also see that
now.
live on your screen. BECO, the side boosters have separated from the center core, and we have the startup of the boost back burn on both of those side boosters, looking really awesome there on your screen.
Flow phenomenon of the center core plume and the two
Now
booster
side
plumes
boosters
interacting.
are returning to Florida under the power of 3 engines. Coming up are a few events in rapid succession. That will be the conclusion of the side boosters boost back burn, MECO, stage separation of the center core and the second stage, as well as SES-1, or the NVAC engine igniting on the second stage. SES-1 stands for second stage engine startup.
Next step in the flight
And as
here
I mentioned previously,
is main
per the
engine
request
cutoff
of
from
our
the booster.
customer, we will not be showing second stage views after SES-1. Additionally, our center core, or stage 1, is expendable today, so we will not be attempting to recover it.
Nice,
but
girl.
we will be following the side boosters back to
Nice,
land,
Jacob.
so you can continue to stay tuned for that.
Center core is now traveling at 13,000 kilometers an hour, 115 kilometers in altitude. Stand by for main engine cutoff at T+4 minutes.
Booster boost back shutdown.
There's
Stage separation confirmed.
main engine cutoff on the center core. Stage separation is confirmed. Stand by for upper stage ignition.
Ignition and full pass.
Good upper stage ignition.
And there we were also able to see and hear
Nice.
the call-outs for the side
Good shot
boosters,
of
boost back
mission
burns
control.
concluding.
MCCX
we had
and
MECO, or main
Hawthorne
engine
there.
cutoff of the center core, as well as stage separation, and also heard confirmation that the NVAC engine has ignited. Now, as we mentioned before,
Fairing separation confirmed.
Got a
and
call
great
on
call
fairing
out there,
separation
also a
there, T+4
confirmation
minute
that the
35.
fairing has separated from the second stage. Again, we will be attempting to recover those fairing halves when they fall back to Earth using our recovery vessel, Doug.
Trajectory is nominal.
Got a good call for trajectories from whatever SpaceX calls their
Now,
GNC.
again, as I mentioned earlier, the center core was not
Doug.
built to land or be reused. It is expendable, having given its all for the mission. We will say a big thank you to the center core. For the two side boosters, the boost back burn.
Okay, so the side boosters are at their apogee, which is the highest point of travel here. It was 114 kilometers, traveling at 2,300 kilometers an hour. They are basically on a trajectory now to land back on the landing pads back at Cape Canaveral Space Force Station. Nice, Dish. There you go.
Yeah, those
there you go.
side boosters are currently on their way back to land. In order to land back on land, we typically have
stop
three
it.
burns.
Center core FTS has safed.
We typically have three burns. They've already concluded a boost back
Great
burn,
shot,
which
Brad.
helps them turn back around and head back towards land.
Yeah, Zenith.
The next burn coming
Kinda
up is
crazy,
the
huh?
entry burn. That's where we'll reignite 3 of the engines on each of those boosters, and that helps slow them down as they enter back into the Earth's atmosphere. Now, if we do have successful landings today, it will mark the 257th and 258th landing of an orbital-class rocket. And those entry burns are coming up here in about
There's no drone ship landing
30
mock. They're
seconds or
landing
so.
back on land.
And again, as I mentioned earlier, the center core will be expended.
Oh, yeah.
And we are not attempting
There's Chris
to
G.
recover it today.
I see him, Ian.
Discovery.
Oh, yeah, it's Chris G right there. I know that guy. That's cool. Hey, Wolfus,
The
what's
entry
up,
burn
man?
is coming up here for the side boosters.
Had a good view.
Entry burn startup.
Okay, double supersonic retro propulsion
And
happening
there's
right
that call out
now.
that the entry burns have begun on the side boosters. And there you can see on your screen.
Stage 2 FTS has saved.
You can see on your screen
Everything's
the
looking
engines
good
have
here.
reignited.
Booster entry burn shutdown.
So Falcon 9 is slowing itself down and also
PY FTS has saved.
using its own
And a short
exhaust
burn.
to
FTS
shield it
saved.
from entry heating.
Short burn for both of those
Okay, you can see
boosters.
the causeway.
Just
There's
under 20
Florida,
seconds.
right
All
there.
vehicles are on nominal trajectories.
Great call outs there. All vehicles
Got a good
on
view of
nominal
Merritt Island right
trajectories.
there and the Banana River.
Now again, we do have one more burn for each of these side boosters
The
coming
road
up
over there on the far
in
left of
just
that
about
screen
30
is
seconds.
SR
That is the
528,
landing burn.
right
It's
to
a
Port
single
Canaveral.
engine burn for each booster. And just one engine is powerful enough to slow the vehicles down and safely land.
Not getting
back
that good of a
on
view
land.
on one of the
Again,
side
we are
boosters
targeting
here.
Transonic.
Okay, the
targeting
booster's
landing
going
zone
slower
1
than the
and
speed of
landing
sound.
zone 2 for today's landings.
5 kilometers off the surface.
Booster landing burn.
First landing burn should start.
And we heard that call out, and you can see on your screen that the engines have reignited.
Landing leg deploy.
Let's watch as these side boosters touch down for landing.
Stage 2 is a thermal guide.
throttle up.
One booster down. Two back down on the pads.
And there you can see on
Damn,
your
that's
screen, we
cool.
hear the crowd here, very excited. We have successfully landed both Falcon Heavy side boosters on landing zone 1 and
That doesn't
landing
suck.
zone 2. With these two
That's
side
pretty good.
boosters, this marks the 257th
That's pretty good.
8th overall successful landing
Girl, get this
of
up
an
to
orbital
Ian.
class
Defect,
rocket.
get this up to 0.
And with successful confirmation of our side boosters landing, that will bring our webcast to a close
Yeah,
today.
right, Gaw? Yeah.
We'd like to thank the United States Space Force for entrusting us with
Glad you
today's
came back.
mission. And we'd like to thank all of our viewers for tuning in. As a reminder, in about 3 hours from now, our 96th and final mission of 2023 is set to lift off from our neighboring pad here in Florida. Be sure to tune in for that one. We hope you all enjoy a happy and healthy new year, and we'll see you back here for an exciting 2024.
Yeah, just that shirt, the Falcon shirt that Jesse had on was really awesome. And there you go. That's SF-52. Pretty good, huh? It's pretty good. Pretty good. Has SpaceX given up on ever trying to recover the center core? Does it depend on the mission? It depends on the mission. Hey, Dish. 99 Luftfalcons. Dun, 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 dun. There is a Starlink launch that's happening tonight, guys. I have to get up in the morning, so I'm not entirely sure. Well, not entirely sure. I'm not going to sugarcoat it. I can't be here for that. But the SF-52 Falcon Heavy, I don't want to miss that. What the heck is the Space Force cooking? Oh, dude, they're having some fun. Huh. That's interesting. That's an interesting orbit. Yeah, we talked about that a little bit earlier. Yeah, John Krause's picture is amazing. Yep. It's the final one, though. You mean you're not going to duplicate what we saw in Kerbal Space Program? I've done double booster landings in Kerbal Space Program with no mods, Fred. It's really freaking difficult to do. Yeah, you heard that right. Double booster landings, no mods. I've done it. And remember back then, guys, with our Falcon Heavy vehicle that we built, remember how we always ended up having to expend the center core? Because it didn't make sense to try and go and get it back? That's weird. I would like to remind everybody for the record that we were doing this in 2016, which is strange. Shit, that's weird. That's weird. Life imitates art. I'm not trying to say I know anything that's going on at SpaceX. It's just a weird coincidence. Time to collect royalties. Elon, pay me! Yeah, that's what I'm saying, Avatar. Yeah. Pay me, fool! He'd be like, no. And I'd be like, all right, man, that's fair. all right, dude. Yeah, Johnny. Yeah. Johnny Thompson. Yeah, we're tread setter over here. That's right. You should see the footage from NASA spaceflight. What are our buddies showing off over there?
Boom, ba boom of each.
Boom, ba
booster
boom, says Sawyer. All right, what's up? Let's see.
I've seen.
Outstanding. Well, looking forward to seeing your photos there, Sawyer. Thank you again for being out in the field, and thank you to Julia for also being out in the field and operating the camera.
This is the NSF track here.
Mr. Beautiful. The second step, a fly. That is both go.
Oh.
Looking away. I wonder who that is. Maybe somebody at the press
Look
site.
at that.
Is beautiful. That is both of the side
Oh, that makes me feel feelings.
boosters. Their plumes interacting with the second stage plume.
The center core.
Yes. Thank you, center core.
She's even larger. It's
Yeah,
an even
right.
larger plume. Because
Right.
it's 9 engines against 18 engines, I guess. No, not 18. Oh boy. 6 engines.
Right. Absolutely beautiful stuff. So
It's
what
amazing.
are
Wow.
we going to see?
That's impressive, dude. That's impressive. I'm sorry. Sometimes what we're seeing on the screen, I just don't think really warrants me saying anything, and there's no point. Like, there's no reason to say nothing.
On the
You
left-hand side there.
All right, Chief. See you, buddy. Oh, man, that's cool. So, as my buddy Alex over at NSF, that's what he was saying. So, the reason why you get this weird flow phenomenon going on here is because where the boosters are right now, there's not really a lot of ambient pressure. They're pretty much all the way up into space, but they're not in orbit, but they're in a spot where the atmospheric pressure is so ridiculously low that the way the plumes move around is something that's very, they can move around really freely. Basically, the gases coming out of the engines basically just expand as much as they can because there's not atmosphere to run into, right? So this flow phenomenon that you're seeing here is the center core with the second stage moving away and the two boosters. So the center core is going this way and the two boosters are going that way, and you're seeing their plumes interact. You're seeing the turbulent forces happening from the engine, from the double boost back burns, and it is becoming turbulent because it is interacting with the center core's 9 engines. So as the center core moves away, once again, the gases can just move around real freely up there. So this plume interaction is something that you wouldn't see if you fired 2 rocket engines at each other down here. It probably wouldn't end very well. But that's what makes this kind of cool flow phenomenon going on there. It's the plumes hitting each other and then shooting out radially relative to the booster at 90 degrees. It's really cool. And notice as they get further apart from each other, you get less flow phenomenon happening. But you still see some plume interaction there between the two boosters, which is crazy. See this right here? This part right here is the two boosters' plumes hitting each other because one is kind of ahead of the other. Did I miss the launch? Yeah. I saw it with binoculars. It was fantastic. It's awesome, isn't it? It's so cool, dudes. John, you got your worm, dude. That's awesome. It looks like the Northern Lights. Yeah, crazy, right? Isn't that cool? Yeah, that's worth the price of admission, man. It did this at Starship stage separation because of the hot staging, John. Yeah, you're not wrong, dude. It was a little bit of a different flow phenomenon because, and both the engines were pushing in the same direction, technically, right? But yeah, when Starship flipped over, yeah, similar. Yeah, absolutely, dude. Good landing? Yeah, double landings. Everything looked good. We got double supersonic retro propulsion. Here, check out the landing view from our... Once again, this is our buddies over at NASA Spaceflight. You guys want to see something wild? Watch this. Hey, WD-40, thanks for the raid, man.
Tight. Stand steady? I don't know. Either way, go throttle up. That would appear to be
Sorbius, 19 months.
Or is that just a booster coming
Thanks,
back?
Thanks, buddy. WD-40, thanks for the raid. Holy
shit.
That's the interburn. 2 candles.
And we'll see one shut off there, and we'll see the other shut off in just a moment. Leading me to think that these will be a little bit more staggered.
Yeah.
Absolutely gorgeous. All right, so next up, Alex, is going to be the landing burns for both side boosters, right?
WD-40, thanks for the raid, man. Appreciate it.
Sort of
hang on. Sorry, look at that. That shot was cool. You can see the...
So that's SR-528 right there. That's Port... So Port St. John is right here. Titusville would be up here. This is the Banana River. There's Merritt Island. Right there. And then... I think that's Port Canaveral right there.
Space Coast as the boosters absolutely...
It's hard to say.
Absolutely haul butt back.
You look beautiful from Titusville. Panic backflips, 15 months. Thank you.
Stuff. Sorry, what were you going to say, Alex?
Yeah, these side boosters
yes, it does.
Will actually initiate the landing burns closer to the ground than usual because it's going to be a 1-3-1 burn. They're going to ignite the center engine, then 2 other engines will ignite to be able to slow down really, really fast, and then they'll shut down, and they're going to be coming down to the ground on just one single engine at the end of the burn. But it's going to be a burn that is... You know, high pucker factor, I guess.
Oh.
There you go. That's landing.
Here we go. Both boosters coming in.
Wow.
Let's listen for the sonic booms.
It's going to be delayed because they're a long way away. Well, that was pretty neat. That was pretty neat. How far away was the launch apart? How far away was launch apart was launch to booster landing pad? 39A to LZ1 is about 10 miles. Probably a little bit. Nah, maybe a little bit less than that. It's close. It's around there though. The core was expended. Yeah, Wolfie. Hey, don't hate the player. All right, don't hate the player. Just shut up, okay? Don't hate the game either. Just shut up. What? The booms took most by surprise at the port. The delay. Yeah, it seems like SpaceX is staggering them on purpose, but one of SpaceX's high-level executives said on Twitter that that's just... You're going to get slight differences in combustion. The fact that, like, the first Falcon Heavy launch, the boosters came down, like, pretty much simultaneously is just chance. Sometimes the combustion is going to be, the thrust output is just going to be, you're going to have, like, a slight variation. And that slight variation might mean that it needs a little bit of a longer burn, and that would end up getting you a staggered landing. So yeah, it's completely random having the boosters kind of either next to each other when they land or a little bit staggered. It just comes down to differential combustion efficiency between the rockets. That happens. Not to alarm you, but the Pistons are currently beating the Celtics. Thumper, 5-month resub. The Pistons are winning something? That's weird. Okay. Anyway, yeah, there you go. Pretty good stuff, right? That's pretty good, dudes. Yeah, Dino, that's a little strange, right? So what I'm trying to tell you is that if the Pistons actually win something for a change, we might want to start like, prepping, because that means the end is nigh. Yeah. I mean, the Lions already won their division. We're pretty screwed, dude. I'm kidding. Only a little bit. Zayden's ice skating to work. Yeah, right. Hey now. Hey. It's the 7th. Yeah, right. Oh, boy. Zuck's already ahead of you there. Yeah, dude, I'm just saying, if he's doing it, maybe, the score isn't even close. What quarter is it, Thumper? Cats and dogs living together. Mass hysteria. Rick, the booster's return is controlled completely by onboard computers. Yep. Yeah, Rick. Yeah, it's... Falcon 9 is basically a radar-guided munition. So think like a smart bomb would steer to its target. Falcon 9 basically does that. It just doesn't impact at the very end. It fires its engine and stops and just lands. But it's the same thing. Heck, some guided munitions have grid fins on them too. Yeah, man. So Falcon 9 on the bottom somewhere, I don't know where it is. It has a downward facing radar, and that downward facing radar is actually looking for the launch pads. They have radar reflective material on the launch pads. That's what those rings are. They didn't just paint the rings on the thing to look freaking cool, right? On the ground landing pads, the ones that are on concrete, right? There's radar reflective material on the landing pads, and Falcon 9's radar is looking for it. It has a downward facing radar that's looking for the thing, and it'll go and land on it. Now, the drone ship. Now, I noticed what some of you guys are saying, like, well, wait a minute, they don't paint the rings on the drone ship. What the heck's up with that? I don't think Falcon 9's radar needs a lot of assistance to find a metal object in the middle of the ocean. The metal's already reflective. Yeah, that's why SpaceX doesn't bother painting them anymore. You don't need to. At least, I'm pretty sure that's what's going on. Could be wrong. Who knows? I thought it uses GPS. No. So, John, I know it's going to sound counterintuitive, but why? Why would you need GPS? That's complicating things. Think about it. Like, looking to communicate with satellites, why would you need that? Falcon 9, the boosters already have inertial measuring units on board. So as long as you input, like, the longitude and latitude of Complex 39 into the flight computers when the boosters go to launch, they'll know the booster doesn't need GPS as a reference frame. That's complicating it, believe it or not. That makes it that's adding an extra step. You don't need to do that. That and GPS probably isn't accurate enough. At least the civilian stuff. Water and steel have the same radar reflective profile. The barge actually cannot really be seen by radar. Oh, okay, Zeppelin. So how do they land then? You sure about that? So the booster knows where it is because it knows where it was. Mm-hmm. Yeah, I know it's, John, it's like super counterintuitive, but it's actually, GPS is actually adding a step. Yeah. It could have a radar beacon. Yeah, it could be emitting a ping, sure. I mean, Zeppelin, if that was the case, why would submarines need sonar instead of radar? Honest question. I mean, I'm trying to learn here. Would you know why the Strongback is still purging? They're getting the remaining propellants out of the plumbing between the fuel tanks and the launch pad, Thumper. Yep. What they're actually doing is they're trying to evac all those pipes of liquid oxygen and bring the pipes back up to ambient temperature. And they do that by shooting nitrogen through them. They shoot nitrogen gas through the pipes, basically not super cold, right? Not liquid nitrogen, just they shoot nitrogen gas through the pipes to get all the liquid oxygen out and bring the pipes back up to ambient. Because you don't want oxidizer inside of a metal pipe. You don't want liquid oxygen sitting in there. It'll rust the pipe, right? Man, you think salt's bad? Liquid oxygen makes salt look like nothing. Liquid oxygen rusts stuff really quick. One ping only, Vasily. Well, Stover one of the guys who developed Falcon Heavy. That's why the boosters are so staggered now. They found out the radars were interfering with each other on Falcon Heavy launches. Maybe. Yeah, you guys got to remember, like, in terms of communications, you got to simplify it as much as possible. If the ship is emitting a beacon and Falcon's emitting a beacon, you're adding an extra step. If Falcon can look at it at its radar and see it passively with the radar, then you don't need the beacon on the ship. The thing will just find it, and that's what it does. O2 is rust incarnate, that's right. Or more likely, it's got an off-the-shelf ILS-based system. Once again, that's complicating things. If Falcon's onboard radar can find the thing, you don't need something like that, Tessa. That theoretically could mean Falcon 9 could pretty much land. I mean, the drone ship, you could land the drone ship anywhere. I mean, Falcon 9 could land anywhere if you have a predetermined coordinate for it. But the radar is what makes it accurate. Did I miss the launch? Yeah, Dama. It was a great launch. Yep. What about Super Heavy in the future? Will the chopsticks be a similar situation to the drone ship? Erudite, if I had to guess, it's looking for the OLM. If I had to guess. Or, so guys, in rocketry, we're talking about a reference position. So, okay, think about it like this. All right. I'm standing right here, okay? I take 2, 1, 2. I take 2 steps to the left. That's what? Let's say that's 2 meters. I sidestep 2 meters, right? Now I'm at position B. I know that position A is 2 meters away. Once again, this isn't a trick question. It's very straightforward logic. So if I take 2 steps back, right? I'm in the same spot. I know that sounds stupid, but that's how guidance systems work. But here's the thing. They use acceleration, right? So you have what's called an inertial measuring unit, right? You're using acceleration. So if I figure out that it takes me a second to go 2 meters, how fast am I going? 2 meters a second. I can use that acceleration to determine position if I need to, right? But I use steps to determine position because we take one step, 1 second, 1 meter. This is making it really straightforward. It gets more complicated if you're going, 100,000 meters that way and then coming back. Hey, lol's 57 months. No, we didn't get any payload pictures. Yeah, and then you do the hokey pokey and you turn yourself about. That's what the missile's all about. I think that's how that song goes. So now, if you think about that step analogy, Falcon 9 doesn't know where that drone ship is, right? It doesn't know how many steps it is away. You could give it some distance, but if it's using acceleration to figure out its position relative to the launch pad, right? Now you have something open. Now you need some type of system to find the drone ship. Right? And if you have a beacon on the drone ship, that means Falcon 9 is going to need to look for that beacon. Right? So now you have 2 beacons. Now you have 2 signals bouncing back and forth off each other. SpaceX eliminated that, and just Falcon 9's just looking for the drone ship with radar. It makes it simpler. And now, with the radar, you have a reference frame relative to position so it can figure out where the ground is. Via the radar ping. The computer does that in real time, which is freaking impressive, dude. That's impressive even by today's standards. Meaning that we've seen hundreds of Falcon 9 landings. The fact that it does it every single freaking time is pretty freaking cool, man. We do that on paper. It's called dead reckoning. Yep. Mm-hmm. Does the Falcon 9 have a phased array radar? I have no idea, Zeppelin. I don't know. It's some type of downward facing radar. If I had to guess, it's something off the shelf. I don't know what has downward facing radar off the shelf, but it's something. Knowing SpaceX, they probably lifted it from like a boat or something. Because that's what they do. You find something that works and then adapt your tech to it. I remember this discussion on lunar missions and positions in space during missions. Yeah, so John, the new hotness with like landing on other planets is that you're not going to get you're landing on planets or moons, right? You're not going to get that reference frame on the ground. So how the hell do you land the thing? Right? So you could use radar to bounce a signal off the ground. That's what they did during Apollo. Apollo had a downward facing radar, right? Actually, they just turned the antenna down. They'd use the same antenna if I'm remembering correctly. It could be wrong though. It might have been 2. I'd have to go look. But that's only going to get you so far. That only tells you your position relative to the ground. You're not going to find a flat spot. So like, let's take Apollo 11, for instance. Neil and Buzz went down and they saw that the computer was going to land them in rocks. It was going to land them in a place that really wasn't a good spot for landing. So that combined with the 1201 and the 1202 alarm, basically from not turning off the docking rendezvous radar. So it is a different system. Not shutting off the docking rendezvous radar actually caused a stack overflow on the Apollo guidance system. So Neil said, frick this, shut all that stuff off, I'll do it myself. And then basically looked out the damn window, looked for a flat spot, and frickin' landed in a flat spot. That's what he did. The new hotness right now does exactly that, but with a computer. So let's take the Perseverance rover from Mars, for instance. It used a phenomenon, well, not a phenomenon, it used a thing called terrain relative navigation. There's a downward facing camera on the lander, and the camera is looking, there's code on it, maybe using a neural net, I'm not exactly sure. There's code on it that's looking for a flat spot based off of reconnaissance photos. It's looking for that flat spot, and it matches picture to picture, and it plots a landing solution and lands in real time. Like just how a person would be looking out the window with a lander being like, okay, that part's not good, I should land in a flat spot. That's the new hotness. It's called relative navigation. Basically where you use a camera and a computer to figure out where you are. That's super cool stuff if you ask me. The radar antenna's at 9 o'clock. Something like that. Anyway. Alright, guys. I gotta get going. I could imagine they probably use ground radar similar to what they use on commercial aircraft for landing. Probably, Rev. Yeah, dude. It's something off the shelf. Because that's how they roll, dude. That's what they do. There is a calculated corridor to descend. Yep. Mm-hmm. Yep. All right. Guys, I have to get going. I might be back for the Falcon launch, no guarantees, but I am not streaming tomorrow. I have some other stuff that I have to do. So I will see you guys on Saturday night for GTA shenanigans on New Year's Eve. Yeah, we're going to play GTA on Saturday, and we'll send off 2023 here with some rockets and explosives in GTA and racing and fun stuff. So I'll see you guys Saturday night. I'll probably kick stuff off sometime in the night. And then, yeah, that's it for 2023. Regular schedule should resume with cities in Kerbal on Tuesday. So that's the 2nd of January. That's when, yeah, we're going to go back to just the streaming grind. So thank you very much for watching, everybody. I'll see you guys on Saturday for the GTA bash. And have a good night. Let's see who we can raid, actually. Let's see if we can drop a raid somewhere. I hope you guys have been having a good kind of mid-holiday thing going on here. Ooh, Italix is still doing his subathon. He's still going. Unbelievable. He's still going. I can't believe that. He's still in the He's still in the character creator? Let's go raid Italix. He's been streaming for like 4 days straight. He is sleeping, but yeah, he's been streaming for like 4 or 5 days. I don't know what his uptime is. We'd have to go check. He's taking sleeping breaks, but yeah, the stream is, yeah, he's been like live for days. He's doing a good old subathon. So let's go raid Italix. Yeah. No, shots. Let's go see what he's up to, and I'll talk to you guys on Saturday for GTA. Thank you very much for watching, everybody, and have a good night. I hope you enjoyed Falcon Heavy. I'll see you later.